morning and good afternoon, ladies and gentlemen. My name is Laurent Oumans. I work as the first secretary and water and climate change expert in the Netherlands Embassy in Hanoi. It is my pleasure to welcome you in the webinar on the water technology in Vietnam, turning challenges into opportunities. This webinar takes place in the framework of a digital trade mission between the Netherlands and 5 East Asian countries, in which we try to encourage business-to-business contacts. The webinar is running on the Zoom platform and will be recorded. If you have any questions, please put them in the Q&A box that you can find at the bottom of the screen. And for technical issues, you can raise your questions in the chat box. In the chat box, you can also find instructions for the language option, because under the interpretation icon, you can find the option to switch to Vietnamese or to switch to English. The Water Technology webinar aims to provide a platform for interaction among the business community, the academics and policy makers. Water managers face daily challenges to keep optimal water quality, quantities, accessibility and connectivity. Technology helps these managers to do this. Technology development is the creative driver of the water sector. In this webinar, we will look at technology needs on the one hand, and that is the demand side, and on technology solutions on the other hand, which is the supply side. The webinar program starts with a welcome message by our ambassador, Elsbeth Ackerman. This is followed by a keynote speech of Ms. Lien Huang, who represents the policymakers. The second keynote speech is from Professor Viet An, who represents not only the academic community, but also the water company sector in Vietnam. He will highlight the demand side. Subsequently, Mr. Piet will give an overview of a demand side in relation to the supply side. This supply side from the Netherlands will then be presented by several Dutch water technology companies. And now I would like to welcome the Netherlands ambassador to Vietnam, Mrs. Elsbeth Ackerman, to give a welcome message to all of us.
Hello, xin chào. My name is Elsbeth Ackerman. I'm the Netherlands ambassador to Vietnam. At the moment I'm in Can Tho. I am at the floating market where many farmers that farm in the Mekong Delta bring their products. We see mangoes, we see other fruits, we see potatoes. It's an abundance of products. The Netherlands has an extensive and long-lasting bilateral relationship with Vietnam, and in the Mekong Delta it focuses on climate and water. Originally it was delta management that determined our agenda. More and more it's other water issues. Too much water, too little water, access to water, the quality of water. The seminar that we are joining today delivers on that. We are hopefully showcasing to our Vietnamese participants what Netherlands water technology has to offer for the challenges in Vietnam, and the Vietnamese participants to the seminar hopefully are able to underline and explain the need for potential cooperation with Dutch counterparts. I hope that you will have a good exchange of thoughts and ideas, and that business-to-business contact will evolve from this seminar. Thank you very much. Xin Cám ơn.
Thank you, Ms. Elsbeth, for this warm and original welcome from the Delta. Next, we will continue the program with a keynote speech of Associate Professor Dr. Mai T. Lien Huang, Director General of the Administration of Technical Infrastructure under the Ministry of Construction. Mrs. Lien Huang, the floor is yours.
Xin chào bà Elsbeth Ackerman, Đại sứ Hà Lan tại Việt Nam. Xin chào mừng các quý vị đại biểu, các vị khách quý đến tham dự thảo trực tuyến công nghệ ngành nước tại Việt Nam, biến thách thức thành cơ hội ngày hôm nay. Lời đầu tiên cho phép tôi thay mặt Cục Hạ tầng Kỹ thuật Bộ Xây dựng xin gửi tới các quý vị đại biểu, các vị khách quý tới tham dự hội thảo lời chúc sức khỏe và lời chào trân trọng nhất. Trong bối cảnh đại dịch Covid diễn ra rất là phức tạp, tôi đánh giá rất cao sáng kiến của Đại sứ Hà Lan tại Việt Nam đã tổ chức hội thảo trực tuyến công nghệ ngành nước tại Việt Nam, biến thách thức thành cơ hội ngày hôm nay. Trong thời gian vừa qua thì lĩnh vực cấp thoát nước tại Việt Nam cũng đạt được những cái thành tựu nhất định. Tuy nhiên vẫn còn nhiều những hạn chế cũng như là bất cập, đặc biệt là phải đối mặt với những thách thức diễn ra như là những diễn biến phức tạp và khó lường của biến đổi khí hậu, xâm nhập mặn, hạn hán, mực nước biển dâng, đặc biệt là vấn đề tốc độ đô thị hóa cũng như là công nghiệp hóa diễn ra đối với các địa phương rất là nhanh chóng. Một trong những vấn đề nữa đó là vấn đề suy thoái, ô nhiễm nguồn nước, ngập úng đô thị, thiếu cái nguồn lực phát triển đối với hệ thống cấp thoát nước hiện nay. Để khắc phục những cái tồn tại và những cái hạn chế để biến những cái thách thức thành cơ hội thì cái việc ứng dụng khoa học kỹ thuật với công nghệ tiên tiến, vấn đề tiết kiệm năng lượng, thân thiện với môi trường trong ngành nước cũng là một trong những nội dung, và đặc biệt đó là những cái quan điểm cũng được Thủ tướng Chính phủ Việt Nam xác định rất rõ trong cái định hướng phát triển cấp thoát nước tại Việt Nam. Thưa các quý vị đại biểu, các vị khách quý, bên cạnh việc tiếp tục nghiên cứu để hoàn thiện những chính sách về pháp luật có liên quan đến lĩnh vực cấp thoát nước thì nhằm tạo ra điều kiện để thúc đẩy phát triển công nghệ ngành nước, thì hoạt động hợp tác quốc tế của Việt Nam về công nghệ ngành nước cũng đã được tăng cường thông qua cái việc tổ chức tham gia các sự kiện, triển lãm, hội thảo quốc tế như triển lãm Việt Quốc Tơ và hội thảo của chúng ta ngày hôm nay. Với sự hỗ trợ và không ngừng đổi mới, sáng tạo của ngành nước Việt Nam luôn mong muốn được tiếp cận, được cập nhật những ứng dụng của công nghệ mới tiên tiến của các nước trên thế giới, trong đó bao gồm cả công nghệ của Hà Lan. Thưa các quý vị đại biểu, các vị khách quý, mối quan hệ hợp tác giữa hai nước Việt Nam và Hà Lan đang ngày càng tốt đẹp. Chính phủ Hà Lan cùng với các tổ chức doanh nghiệp cũng như là chuyên gia Hà Lan đã dành sự quan tâm đặc biệt trong vấn đề phát triển bền vững của vùng, trong đó vùng đồng bằng sông Cửu Long cũng là một trong những vùng đất có ý nghĩa quan trọng trong việc phát triển kinh tế xã hội của Việt Nam. Thông qua những cái công việc của tư vấn Hà Lan trong việc lập quy hoạch vùng đồng bằng sông Cửu Long thời kỳ 2021-2030 dựa trên yếu tố về cốt lõi về nguồn nước và hỗ trợ nghiên cứu triển khai các giải pháp cấp nước sạch sinh hoạt cho người dân ở khu vực Tây Nam sông Hậu. Mong rằng doanh nghiệp ngành nước giữa hai nước Việt Nam Hà Lan tăng cường hợp tác và chia sẻ kinh nghiệm lẫn nhau, chung tay biến những thách thức thành cơ hội như tiêu đề của hội thảo ngày hôm nay. Xin trân trọng cảm ơn.
Thank you very much, Ms. Lien Huong. Our second keynote speaker is Professor Nguyen Viet An, Director of the Institute of Environmental Science and Engineering, and also the Vice President of the Vietnam Water Supply and Sanitation Association. Mr. Viet An, the floor is yours.
Thank you, Lauren. You can start with my slides. So this is my pleasure to share with you information about water sector in Vietnam. In this presentation, I will highlight some fast growing and emerging issues in the water sector, something we have been doing to meet the challenges, and some opportunities for business I would like to highlight. So let's start with the Vietnam urban water. Now we have 39% of population living in urban areas, and to supply water for this population, we need about more than 10 million of cubic meter of water per day. And so far we can provide 89% of urban population with a centralized water system. With a lot of effort, we have managed to reduce the non-revenue water over the last 10 years from 31% to 19%. In some companies, the non-revenue water percentage is already below 10%. In the photos, you will see some new technologies have been applied. For example, the photo in the middle, the first line, is a frequency inverter, which is now applied commonly in clean water tanks, clean water pumping stations. The lamine plate settlers, the next photo, and the upflow biocarbon filter for pre-treatment of water polluted with organics and ammonium, which are now among emerging pollutants in many water sources in Vietnam. We have to use reverse osmosis for some treatment plants now, even though it's still very costly in both the south and the north systems. And the first water treatment plant already applies ozonation for removal of organics and for disinfection. Next, please. Talking about wastewater in urban areas, so far we could treat only 15% of wastewater generated. But the number of wastewater treatment plants is still growing. And there are different technologies applied, including different types of activated sludge, oxidation ditch, SBR, trickling filter, and waste stabilization ponds are also used. Over the last 5 years, the investment for the urban wastewater only is already more than $1 billion US. So in coming years, we might need about from 8 to 10 billion US dollars to treat all wastewater generating from urban areas. And we need from 3 to 6 billion US dollars to have 100% of urban water supply. But please pay attention that the number of cities is growing. So we need more and more efforts, and not only from the state budget, loans. We encourage private sector to take part in, especially in the water projects. Next, please. This and next slide, I just would like to show the in operation water wastewater treatment plants in urban areas with different technologies. Next, please. Now, about industrial wastewater management. We have more than 300 industrial parks, which has average occupation ratio is 73%. And by law, all industrial parks should have centralized wastewater treatment plants. And so far, we could have 80% of these treatment plants meet the effluent standard. The other are still under upgrading. They have to improve their technologies. Even they have to move from class B to class A of the effluent standard. So we have a lot of room for the business for providing technologies and equipment and so on. Next, please. These are some ongoing measures being applied for industrial wastewater management. The polluter pays principle is strictly applied, and very soon after issue of the new environmental law, the National Congress just has approved this new law. We are switching from the class A, class B applied for everywhere, the effluent standard, to the standards based on the river receiving capacity. So for each river basin, we start to develop the effluent standard accordingly. And the government now is encouraging to develop eco-industrial parks with the industrial symbiosis I know the Netherlands is very strong in this, so I hope we could find a lot of chance for cooperation. And compulsory automatic mooring station for the effluent of industrial and urban wastewater treatment plants with a capacity more than 1,000 cubic meter per day, which should transmit the real-time effluent data to the authorities. Next, please. And these are some examples of the smart water solutions being applied and more applied in water and wastewater companies. So we have online monitoring of water quality, of water level, of water leakage, and online and real-time automatic meter reading, and connected with customers management systems and and property management, etc. So smart water solutions are now being highlighted in many water companies, and it will be in the focus in the coming 5-10 years in the Vietnam water sector. Next, please. This is some examples of very high demand, the big needs to provide suitable technologies for removal of specific pollutants from different industries to meet the effluent standards, as I mentioned. Solutions for process control and optimization to save energy, to have less sludge produced, etc. And emergency control solutions. For example, we now have the new decree forcing the blacklist industries have to have the effluent pond to make sure fish alive in the ponds before wastewater can be discharged to the receiving bodies. And the other options are also under the development. So emergency control for wastewater and for other pollution sources, very interesting topic for the cooperation. Next, please. This shows new models of a smart city where waste is being managed, treated in the integrated way for resource recovery. So far, we are talking about that. We are developing the models, and we are discussing with the cities. But more than 20 cities in Vietnam already is developing the smart city plan. So integrated waste management with the resource recovery solutions is one of the important components of the smart city development. So these are some examples of our studies, and this is also a very interesting topic for the Dutch companies to work in. Next, please. And you know that flooding is very common issues in many cities in Vietnam, especially big cities and coastal cities. This shows two examples of sustainable urban drainage solutions in the north, Eco Park next to Hanoi, 500 hectares, and Phu My Hung, 750 hectares, Ho Chi Minh City, where green space, water retention, rainwater storage and infiltration, etc. are being applied. So we need more models like this, and we need the design standards, and we need the equipment, we need the, from planning to the solutions. So suits is one of the interesting topics. Next, please. So here I would like to highlight some opportunities for water sector business. So the private sector participation is encouraged. This is a policy of the government. So investors are welcome, and we have the growing needs, increasing demand, where we have emerging challenges, potential opportunities in the market, in the water supply is solutions for non-revenue water management, smart water concept and solutions, and specific technologies to remove specific organics, nitrogen, manganese, salt, and other substances. For wastewater, also specific technologies for specific pollutants removal with efficient performance like energy and chemical saving, space, footprint saving, etc. And we are starting to talk about the resource recovery, especially from the solid waste, sludge, and wastewater reuse. Industrial park with go eco, also good solution, a good opportunity, and greens and smart city with the concrete solutions like rainwater and flood prevention solutions. And very important, smart technologies and very high demand from the planning, from the solution to the solutions. But because the companies cannot do everything in one day, so we need the integrated and long-term planning and step-by-step solutions. And this is a very good opportunity for the corporation. So that is all from me. Thank you very much for your attention. Thank you.
Thank you very much, Viet An, for this overview of the water and wastewater sector in the urban and industrial areas in Vietnam. Thank you for highlighting the investment needs of billions of dollars, which of course generate the business opportunities in the water sector that you mentioned. If participants have any question for Dr. Viet An, please post them in the Q&A box, which you find at the bottom of the screen in front of you. And Professor Viet An will be willing to answer your questions. I haven't seen any question in the box yet. To further inspire you, I would like to show a short video of the Netherlands Water Partnership, in which we see some of the challenges and demand for technologies in the Netherlands.
Water. It's in every one of us, as a source of life, a connector of worlds. Water calls for a sustainable future, a delicate balance between humanity's progress and natural resources. We need to invest in transformative, integrated and inclusive solutions, turn threats into opportunities, translate research and market insights into breakthrough innovations, to build a prosperous future, to ensure there is a tomorrow for the planet, for its inhabitants, for present and future generations. We are the Netherlands Water Partnership, a network of Dutch water organisations working together on innovative and future-proof solutions for local, national and global water issues.
Our next speaker is Marco Piet from Royal Haskoning DHB, and he will further elaborate on the technology market. He directed a study which identified interesting Dutch technologies that potentially have a market in Southeast Asia. Marco, please share the findings of your study with us.
Okay, good morning, good afternoon, everybody. Thank you for joining our brief presentation on the preliminary results of the matches between the demand in Vietnam and the potential supply side in the Netherlands. Can I have the next slide, please? I will briefly share the objective of the market study, the trends and focus areas in the Netherlands, and will conclude with an overview of potential matches. In the next slide, so basically the objective, the study is for RVO is to provide insight into the opportunities and challenges for Dutch water technology sector in 5 Asian countries, including Vietnam, and to make recommendations for the Dutch government to support these businesses in entering the market. Just to be clear, the water technology sector in this study consists of activities in which water is treated by technology. It comprises of organizations and companies. We give services and products based on knowledge, technologies, processes, and techniques for the treatment, monitoring, adding or removing substances of water. Topics of water technology include industrial processed water, domestic and industrial wastewater, drinking water, and water quality monitoring. For the study, we conducted a thorough desktop study, held a survey under about 200 related businesses in the Netherlands, and interviewed 10 stakeholders per country. I also would like to use this opportunity to express my gratitude for the people that have contributed already. This presentation is also held to get additional feedback and input from you, hoping this will lead to more concrete matches. So if you have any questions or remarks, please let us know. As also the study hasn't finished yet. Next slide. So globally, basically, the Dutch water sector is known for their innovative, robust, and efficient treatment technologies, either developed with own resources or in partnership with public-owned companies. For instance, we have 35 knowledge institutes, 21 water boards, and 10 water supply companies active in the Netherlands, next to all the engineering and consultancy companies. In the past, many companies already have, after being successfully in the global market, been consolidated by larger international enterprises, like, for instance, Stork/Xflow. It was acquired by Pentair, Noord by Cabot, Nijhuis by Sauer, Grondbij by Sweco. The largest share basically of the companies are these 1,000 private owned companies that are active, of which 80% are small to medium enterprises, basically up to 50 employees, and which are thus also the main target group of this study. Next slide. So on this slide, basically this is the focus of the Dutch water technology sector, comprised in 6 bullet points. One of the main focus points in the Netherlands are basically the micropollutants, as the sources for drinking water become more and more polluted by, for example, microplastics, hormones, and pesticides. Research programs include both development of new projects, like special membranes and advanced oxidation techniques, and application tests with a combination of known techniques. For instance, application research of powder activated carbon, ozone, etc. The drinking companies want to use the value in the source water and gain also energy and raw materials. This also to prepare for the energy transition and play into a more circular economy. The wastewater sector in the Netherlands consists of several water boards, which are responsible for the cleaning of the municipal wastewater. The main focus of the wastewater field is the recovery and reuse of valuable components from the waste stream, higher effluent quality, less environmental impact, and reduced costs. An increase of computerized control is used to increase the performance of wastewater treatment plants and reduce the labor that's needed for daily operations. So basically, we are looking at smart combinations, recovery of valuable materials and energy, smart water, membrane techniques, reducing footprint, land, chemicals, CO2, and which also results in a lower TOTEX, total cost of ownership. Next slide. So we compared the potential supply in the Netherlands, which of course provides a wide range of solutions offered by many small and medium enterprises, and the current demand of Vietnam. And basically the demand as explained by the previous speaker, and as a result from our study. At the same time, we had to take into account the potential barriers, like different culture, the challenging business climate, also for instance, skepticism towards Dutch technology, whether they would work in the Vietnamese environment. With that, we came also for suggestions for the required support from the government, but also utilizing more the enabling environment to link and promote Dutch solutions via already active Dutch companies and organizations, like for instance also Phái. Next slide. So this is an overview. In this overview, I will share the preliminary matches that we found for the different challenges. It's a bit a lot of text, small letters, but per challenge, as you can see on the left, we categorized potential solutions for into basically in data collection and monitoring, analyzing data, and providing smart decision support systems, basically the software, and separate treatment solutions, the hardware. As many systems can be used in the water supply and wastewater sector, we did not make a separate classification for them in here. Looking at the main challenges for Vietnam, and basically the challenges on the left are in random order and not by importance, we have put some examples for solutions in this overview. Of course, there are a lot more solutions available, and a lot of more will be included in the final report. The goal basically is to pinpoint if you have a certain request or question or challenge, you can look at each of the sectors and find your brand name or solution. As an example for a couple, for monitoring the water quality, predicting and controlling, the NPC buoy controls basically algae blooms in large lakes and reservoirs. Right? It monitors the water quality in real time and uses the data to predict and control algae blooms by making use of ultrasound to control the algae. As was mentioned, saline intrusion is becoming also more and more a problem in Vietnam. Main solutions consist of membrane techniques, like for instance here I mentioned Ceramec, which combines ceramic membrane units into one vessel, which provides basically it's a more cost-effective and compact method to remove dissolved components from the water stream. In the combined with 6, which stands for suspended ion exchange process, that's designed to remove dissolved organic carbon from the water and basically helps to improve the membrane filtration performance. It prevents membrane fouling. Another major challenge, as mentioned on the left, is the increase of pollution in the environment and water. I think it was mentioned before. The surface water in the rivers is locally polluted by organic pollutants such as oil, waste, and solids. For instance, for the solids, there are end-of-pipe solutions like recently, I think also in Vietnam, the interceptor from ocean cleanup, but potentially another solution is the bubble barrier. Especially the water supply sector has to deal with an increase of pollution due to untreated wastewater released by towns, industries, and agricultural activities. Besides that, micropollutants like microplastics, hormones, and pesticides are also becoming more and more a problem in Vietnam. So real-time monitoring and adequate treatment of the water quality is very important. Some solutions are specific water quality controllers, for instance by EWS, which analyzes data in real time and makes smart decisions possible. Other technologies are of course OPIR, but also treatment techniques like advanced oxidation, which uses a combination of both UV irradiation and peroxide to prepare drinking water by removing and destroying hazardous components. So these are all end-of-pipe methods, but there are also solutions specifically designed to remove pollution at the source, like in hospitals, like the pharma filter. Pharma filter reduces the amount of hospital waste and completely purifies wastewater. It filters and removes basically this medicinal residues and other micropollutants at the source. Other industrial solutions are, for instance, EcoFat, which can recover fat from sludge, as also recovery of valuable materials, or Torwash, which reduces the volume of sewage sludge waste stream, reduces biogas, from which the effluent and potentially recover phosphorus. So for us, also next step is identifying all solutions that are offered in the Netherlands and create more matching for specific challenges and issues. So if you have anything to add or more questions, please let us know. This is the end of the presentation. Thank you for attending this.
Thank you very much, Marco, for your oversight. It shows clearly that Dutch companies can deliver some products and services that are in high demand by Southeast Asian clients. In a later section of this webinar, we will come back to this B2B and to the Dutch and Asian business connections that can be explored during this webinar. Now I'd like to go to the next block of speakers who provide more details on some of the Dutch solutions and innovations. I will give the floor to several Dutch speakers, the first of which will be Ivo from Drainblock. Ivo, the floor is yours.
Thank you very much, Levon, for the short introduction. I will provide you with a brief overview of the Drainblock business. We provide sustainable and practical solutions for the everyday challenges of water resources management. We actually focus on 3 areas, one being water treatment, the other one landscaping and agriculture, and a third one, water retention and infiltration. And this presentation is on the latter one. Before I will show you some of the great solutions and options that we can provide, I will first demonstrate the technology with the use of some videos. Yes, next slide, please. Well, I got here 2 buckets. One is filled with the drain block and the other one is filled with water, almost up to the green line. Now, imagine that you have a drain block underneath your infrastructure, let's say your parking area. Normally, when it started raining, you would have a runoff and the water would go into the stormwater drainage system. But not with the drain block. All water immediately enters in the blocks. And from the blocks, it will dissipate into the soil. And as you can see, the water line is almost barely off that green line. Next slide, please. So drain block can absorb almost its entire volume in water and will release it to the soil. It's 100% natural and environmental friendly product. It has a lifetime of over 50 years and it allows extreme freedom both for the designer as for the installer. It's so practical and easy. Above that, it is very light, only weighs 80 kilograms per cube, but it's very strong and therefore perfectly allows for double land use. Arguably, best of all, no maintenance. Well, how about all the sediments, I hear you think? Next slide, please. Yes, that's correct. Sediments are the enemy, of course, of the system. So before we take water, polluted waters to our reservoir, we will always first install a filtration step. So polluted water comes in, we filter out the sediments and only the clean water will go to the reservoir and the clean water will then infiltrate into the soil. Next slide, please. Yeah, next. This is a typical project, a typical situation in the Netherlands. So what you see on the right picture is just a parking area. But the water from the roof and from the parking areas enters into the gutter, and underneath the parking area, there is your reservoir, a drain block reservoir. And from there, the water can only infiltrate into the soil. There's no more stormwater drainage system needed here. Next slide, please. This is a significantly bigger reservoir, almost 1,000 cube. But the client in that project did not allow for water infiltration. So on your bottom left, you see a black liner. This reservoir has been constructed with a complete liner surrounding it, and all the water is retained within the reservoir. Now, that means that the water in the reservoir is freely available for water reuse, watering your garden or using for agriculture or any other purposes. Next slide, please. Well, this is a very interesting project here. I show some of the great capabilities that DrainBlock provides. You see a slope road. Well, previously, when it started raining, all the water ran down to the lowest point on the road, and there was a flood. DrainBlock, however, has the ability to hold water against gravity. So blocks have been installed alongside the road. Rainwater enters there, even on the slope. The blocks hold it and will infiltrate it immediately into the soil. So there's no more runoff to the lowest point, no more floods in this location. This was China, Qingdao. Next slide, please. That is even closer to your home. This is a project in Hainan Island, just off the coast from Hanoi. And in this project, blocks have been installed underneath the green belt on the left and the right side of the road. Now, very often I hear people say, well, come on, Ivo, look at this. This is peanuts. This is too small. You know how much rain we have here in Asia? Yes, but the Chinese don't do it for nothing. I mean, if you do this, next slide, please. For kilometers on the left side and the right side of the road, you will also create a reservoir of thousands of cubes, but just in a very different shape. It's a very long, narrow reservoir. And the good thing about these reservoirs are that the water does not need a conveyance system to be transported from location A to location B. Water infiltrates right where it falls. You see the grate on the right top corner. Water infiltrates there and is readily available for the environment, for your plants, trees, and the rest will just infiltrate into the soil. Well, this was my brief presentation. I hope you can see that we can provide a practical solution for almost every challenge that you have. If you have any other question that cannot be answered in the Q&A, please drop me an email or just pick up the phone. I'll send you my contacts later on. Thank you for that.
Thank you, Ivo. And I see already questions popping up in the Q&A box. So I'm encouraging everyone to participate. After Ivo, our next speaker is Jan Slange from Witteveen and Bos. Jan will elaborate further on the industrial water and wastewater technology. Jan, the floor is yours.
Thank you very much, Mr. Laurent, for your introduction. Good morning, good afternoon, ladies and gentlemen. My name is Jan Slange. I work for Witteveen and Bos, consulting engineering firm with headquarters in the Netherlands and also an office in Ho Chi Minh. I would like to tell you a little bit more about sustainable and efficient solutions for industrial wastewater. Next, mainly focused on the anaerobic treatment. Why on anaerobic treatment? Because, as the previous speaker also said, there is much interest for reduce the energy consumption and also the sludge production. And that's exactly what is the benefit of anaerobic treatment. It generates renewable energy through biogas, converting the chemical oxygen demand into methane. And methane or biogas can be used in a boiler system or in a combined heat power generating electricity and heat. Compared to conventional aerobic treatment, it has a much lower sludge production. And the sludge has good quality and you can store it for even years. It has a small footprint, much smaller because the reactors are smaller and you can apply a high loading rate on these reactors. Another advantage from anaerobic sludge is that it remains active for long periods without any feeding of wastewater. This is typically applied in industries which have seasonal production. The anaerobic sludge remains active for more than a year, and you can start up quite quickly when you start feeding again. It's also applicable to many industrial wastewaters, especially in the agri-food, but also for chemical industries, paper and pulp. Two common types of anaerobic reactors are the UASB type, upflow anaerobic sludge blanket, and the taller one on the right side, the IC, internal circulation, or EGSB reactor. Next. But it has also some challenges to operate anaerobic treatment, and in any case you need an aerobic post-treatment because anaerobic treatment does not remove nutrients and cannot meet the class B or class A quality regarding COD and BOD. In picture 1, you see the top of an upflow anaerobic sludge blanket under normal and good operating conditions. The second picture, picture 2, you see the same reactor after the disturbance because the operator didn't pay attention to the loading, and you see foam formation starting, and finally it resulted in washout of most of the anaerobic sludge to the next treatment step. Anaerobic treatment is mainly the bacteria is in the granular form, and you see the good granules on picture number 3. With a small, they are very small, but can stand a high upflow velocity. However, in picture 4, you see the same granules after 2 months operation, not taking into account good nutrition. Lack of nutrition and other elements, metals, cause degradation of the granules and reduce of the removal efficiency. To restore this, you have to seed again new sludge. On picture number 5, you see what is the impact on a poor working anaerobic reactor on the post-aerobic treatment. You see the sludge is black, caused by washout of anaerobic sludge into the aerobic system. And in picture number 6, you see another impact, a lot of foam formation, also due to poor performance of the anaerobic reactor. Next. What we see in practice is more and more anaerobic treatment plants are applied. However, they don't work always according to design, or the operation is usually less efficient. In this case, we show you 2 examples in which the design was 75% COD removal, but in practice, they only reach 65% removal. After good monitoring, improvement of the plant, and optimization, we were able to increase the removal efficiency to 85%. And in the 2 pictures below, you see the Sankey diagram on the mass balance, starting with 10,000 kilogram, and you see the difference in biogas amount in the 65% removal efficiency and 85% removal efficiency. 85% removal, you produce 1.3 times more biogas compared to the 65. But also important is the load to the aerobic treatment, post-treatment, when you have only 65% is 2.3 times higher. That means you need also a bigger, much bigger, 2 times, 3 times bigger aerobic treatment, and you produce more sludge. Next. Here you see the combined mass balance of the anaerobic and aerobic treatment, achieving the same effluent quality. And at the bottom, you see also the amount of aerobic sludge which is produced and the difference. This all together causes impact on cost. The 2.6 times lower energy consumption pays back in energy cost, and also the aerobic sludge disposal will become more and more expensive. Currently, in many countries, in Asian countries, sludge can be disposed to landfills, but in near future, you need dewatering, drying, and probably even incineration, which increase the costs. To give you an overview of the cost comparison on these 2 examples, you will see in the next slide. Next. So this is a summary of the normal operating and optimized anaerobic and aerobic treatment plant. And you see the difference in biogas production, the benefits for the biogas in the boiler in euro per year. Also, the electricity production is much higher, and the electricity consumption in the aerobic treatment is, of course, 2.6 times lower. And the general benefit. This is for a treatment plant with a capacity of about 2,000 cubic meter with 5,000 milligrams COD, but can be made for every other treatment plant. And the result is that this achieves a better effluent quality, able or more compatible for reuse with additional treatment. Next. Yeah. Thank you for your attention.
Thank you very much, Jan, for this elaboration on the importance of a proper and optimized anaerobic water treatment. The next speaker I would like to introduce is Anke Verheij from Vitens Evides International. She is the Deputy Program Coordinator of the Waterworks program, which is a Dutch-funded program to support 4 water companies in the Mekong Delta to make them not only technically better, but also financially more attractive for investors. Anke, could you explain the project and the results?
Yes. Good morning, good afternoon, everyone. I would like to provide you more information on our water operator partnership in the Mekong Delta, especially focusing on climate adaptation measures. We started this project in the beginning of 2019, and it is a water operator partnership where we, like Laurent already explained, collaborate with 4 water supply companies. These water supply companies are Kantawasco, Kantatuwasuko, Hawasuko, and Soktangwako. So as you can see, we work in 3 different provinces. We also collaborate with the Dragon Mekong Institute of Kanto University, with the Embassy of the Kingdom of the Netherlands, and we as Phái, as Dutch water operators. As you can see in this map, this presents the urban water supply system of our partner water supply companies. And for example, in Soktang, you can see that this is a decentralized network, which also brings several challenges. The water companies, they use both ground and surface water. In Soktang, they mainly rely on groundwater. In Haoyang, they use both, and in Kanto, they only use surface water. And in this water operator partnership, we provide technical assistance. We call it peer-to-peer support between Dutch experts and experts in Vietnam. So for example, experts that are involved in our projects have worked for 30, 40 years, for example, for Evides, have been involved with the development of reservoirs and know the different challenges related to this. And also there are experts involved that recently developed a long-term resilient water supply plan for one of the water supply companies in the Netherlands. And these challenges and lessons learned are shared with our partners to best support them in developing their long-term water supply plan. So we support the water supply companies to become resilient utilities. And as I explained, we work per water supply company. We develop a long-term resilient water supply plan 2050. We provide support based on this long-term plan with developing more specific adaptation measures and investment proposals, and also provide support in implementing these adaptation measures. To start, it's needed to do a water supply and demand analysis to look into climate change and human impact on the Delta. The previous speakers already explained a little bit about this. The main challenges of the water supply companies are salinity intrusion, pollution, and also shifting from groundwater to surface water use, because the use of groundwater is causing land subsidence. Because some more information was needed for the water supply companies to be able to come, to select, for example, canals to as an intake source. For example, on the right side, you can see a map that provides information on the salinity intrusion, and this was created by Sabra Islami, and we looked into different scenarios and specifically focusing also on the smaller canals, because these are at the moment the sources for our partners. So then, based on that, we had several workshops where we looked at the current water supply system. We had brainstorms about different possible adaptation measures, and that would be feasible for the partner water supply companies, looking at the future water demand, on the water quality of both ground and surface water. So then, what are the different options? Well, this is general for partners, but per water supply company, we're looking into specific measures to take. So an option is to change the source from groundwater to surface water. Advanced treatment, such as reverse osmosis. As you can see here, this treatment technology was installed in our previous project we had with Soktan Wako, this desalination plant. Another option is to add storage. Currently, reservoirs for drinking water supply are being developed in the Delta on a small scale, but also managing aquifer recharge is a possibility. Another option is to get the water from elsewhere, more upstream, in another province. And for these different adaptation measures, it's important to take into account the technical solutions, but also financial, institutional, social, and environmental. So we're looking at all these different criteria, and as water supply companies ourselves, we can help our peers in the Mekong Delta with selecting the best possible solution for them. And if there are any questions, please ask them in the chat. Also, to go more into detail, but in these 5 minutes, I kept the presentation quite general, but if you'd like to have more information, please let me know. Thank you.
Thank you, Anke, for your explanation. Now, I would like to invite our last speaker of this session on the Dutch technology supply. Our speaker is Erik Roesink from NX Filtration. Membrane technology is an important field of innovation, already mentioned by Professor Viet An. Please, Erik, explain what your company can contribute to addressing the challenges in Vietnam.
Yeah, thank you, Lauren, for this nice introduction. Yes, my name is Erik Roesink. I'm next to a professor at the University of Twente, also 6 days a week, an entrepreneur, and started a new company called NX Filtration. It's about hollow fiber membranes, and a very innovative, efficient technology also to be used in Vietnam. Next slide, please. You heard already that Marco Piet told you about Ixlo, Pentair, Norrit. I was one of the founders of Ixlo in the mid-80s. Company was finally sold to Pentair, and then I left the company and I started a new company called NX Filtration. And this company is focused completely on hollow fiber membranes, and then in the form of a nanofiltration membrane, to be a bit more specific, specifically designed to remove micropollutants, all the nice, nasty compounds which we do find in waters all in the world, also in your country. It's called, you could call it a spin-off of the University of Twente. We have quite a good team of experienced people, a lot of experience. We're headquartered in the Netherlands. And I'm here to present my technology. Just to be sure on forehand, this is a very innovative technology which could make in one simple membrane step drinkable water from the Mekong or from wastewater. And since we are only making membrane modules, we are looking for equipment manufacturers, partners, installation specialists, end users to become very active and successful in Vietnam. Next slide, please. You see here our 3 key markets for our product, which is typically to make drinkable water, drinking water from surface water, except, for example, your Mekong River, all kind of rivers. We're very active in all kind of industrial wastewater programs, also reuse, and an important market for us is the reuse of municipal effluent, which is also in your country, which I saw in the first presentation. You have a lot of municipal biological treatment systems, and the effluent there can be perfectly reused for all kinds of applications. And by the way, that's an application we are working on very hard also in Europe with Witteveen and Bosch, which you heard in the former presentation, or with Haskoning in a former presentation, but unfortunately, they forgot to mention that also hollow fiber nanofiltration is a very efficient way to remove micropollutants from wastewater. Next slide, please. So in fact, what I mentioned already, nanofiltration, hollow fiber nanofiltration is a perfect one-step treatment. That means we have only a very minor, simple pre-treatment, and we can produce in one step a drinkable water quality. Certainly when we are dealing with surface water with a very low salinity is still possible. We are not desalination, but we do need, say, fresh water, and then we can do the job in one step. So that means also, in the next slide, please, that you see we do have quite a bit of advantages over, for example, reverse osmosis, which is considered and also mentioned before as a relatively expensive operation. That's because of the high pressure you need. Nanofiltration is much more open, so we allow minerals to pass, which is favorable for making drinking water. That means also our energy consumption is relatively low, say 0.3 kilowatt hour per cubic meter. And if you put everything together, also the very low use of chemicals, so no waste. We do have a very low CO2 footprint, and then the operational cost will be around 0.2 euro cents per cubic meter, depending a little bit on the size of the treatment. Also interesting to mention that our membranes are what we could call low fouling. You heard already some about fouling in the Haskoning presentation. And if you have fouling, which you always have finally in some way, at some moment, you can really clean our membranes also with very oxidative, harsh chemicals like chlorine. So I think this is very important new technology, enabling a lot of new opportunities in dealing with surface water, wastewater, and also groundwater. Next slide, please. Yeah, this is some examples. By the way, you see myself here at the small picture at the right side, but also that's interesting to mention, the ambassador of Vietnam in the Netherlands, who have visited our company in September this year, and I think we made him very enthusiastic about our treatment, and he also pointed out already very interesting application in your area. And here also we are touching the situation like in Vietnam, like in Holland. We do see droughts, we do see climate change. We see that water companies like Vitens, which you heard in the former slide, is using enormous amount of groundwater to make drinking water. And that's heavily under pressure because it's getting so dry even in our wet country and in your wet country, Vietnam and Holland. So there's a big pressure also in Holland to use surface water, which we have demonstrated here in this container. And we invited all important people, even your ambassador, to have a glass of water with me and convince them that this is the way to go in the future with our hollow fiber nanofiltration membrane technology. Next slide, please. Yeah, this is an example of what we already realized on large scale in the Philippines. There is a lot of surface water colored, partly polluted. This is a well water, and here you see our system in operation. And as I repeat that we are supplying you the modules which you see on the picture, but we do need partners who can build this type of systems in your country. And then we also can use the help of Witteveen & Bos and Haskoning, of course, and other consultant companies. Please, next slide. Yeah, as I mentioned, we active in treating municipal wastewater in Europe. Worldwide we see a lot of micropollutants, pesticides, nanoplastics, insecticides popping up in wastewater, which are not treated well enough by biological treatment. So there's a very good chance to integrate. I would not call it end of pipe, but to integrate hollow fiber nanofiltration in the process and create a perfect water for high quality use, even for drinking water. And we have demonstrated that with our nanofiltration, we can do it in a very simple membrane step, minor pre-treatment. We take the effluent direct on the membranes, and then we have a very high retention. We can even play with the membrane type. We can typically go higher than 80. Even if we take a more dense membrane, we can even go higher than 90 if required. Please, in the next slide. So you see here that we already quite active worldwide, from the United States to China, Philippines, also Indonesia. We just installed quite a bit of large-scale installations in Indonesia. Time is too short to go in that application. It's also river water, by the way. In Europe, next to water, we do also quite a bit of beer and wine filtration. So if there is wine or beer filtration in Vietnam, please give me a call. Next slide. Yeah, here you see I'm discussing with your ambassador, and the next picture would be that we drink together a glass of water. We already are quite active in Vietnam for a startup company in spin-off company in the Netherlands, though we already have over 50 people, 2 locations in the Netherlands, so we're not that small anymore. Via Saxion, which is a local university, we already put an Explorer, which is a small test unit, in one of your universities, but we're happy to open cooperation with more universities. One OEM, an installation company called Pernam, is already good contact. And as I told you, your ambassador is already very enthusiastic in using our technology. And yeah, as I told you, we're very happy and open to pick up all kind of cooperations to show our capabilities in treating surface water and other waters in Vietnam. Next slide. Yeah, this is in the middle slide. You see one of my colleagues, Professor Futselaar. He is from a local university. As I told you, I'm myself a professor of the University of Twente. And at the right side, you see students very enthusiastic working with our test installation to demonstrate that you can treat Mekong water in one step into drinking water. So that means we have already done the first steps in Vietnam, and we see huge possibilities, but we need partners to help us. We cannot do it alone. And that's what nobody can do. Nobody can do it alone. You need cooperation. Thank you for your attention. Questions, please do it in the chat box. I will send out my mail, and I'm happy to share this presentation. Thank you for your attention.
Thank you very much, Erik. I already see a question for you, and I see two questions for Anke as well. We will now go into the Q&A session of this webinar. I invite all participants to open their video, their video, so that the other participants can see all of us and can raise the questions. I invite Anke to answer the questions that are still pending, and let's see whether we get some new questions in the box, in the Q&A box. I see a question coming for Jan, and also a second one for Erik. So I hope you can now answer these questions, and maybe if the answers are leading to follow-up questions, feel free to ask those questions. I can already announce that at the end of the webinar, we will show the email address to which you can send an email in order to request the presentations that the various speakers have been showing us. So you will get access to that information, including their email addresses. I follow the Q&A session and the answers that our presenters are providing. There were previously some questions on the law and on the financial capability of Vietnam. Maybe I can invite Professor Viet An to respond to those questions for a few minutes. What are the especially the measures that are put in place to make sure that the law is implemented and that there will be enough finance to stick to the law?
Okay.
Could you please elaborate?
I think the question is very interesting and very challenging to answer or to realize it in the practice, because very often we face a problem. Law has been issued, different paperwork, but in real life, it's very difficult to implement it because of different reasons. But as I mentioned, we have more and more strict regulation enforcement. And if the principles polluter pays applied, and very strict control and inspection, plus public hearing, the polluters have to follow the rules. Under the law, we have a decree providing detailed guidance to implement the law. And under the decree, we have the circular with more technical instructions, and how the system is working on that. And if something behind the reality, the practice, we have the update. It's not easy to update the law, but it's easier to update the decree and circular. And that is what Vietnam is doing.
Yes, thank you for your answer. And regarding the financial sustainability of the water sector, there was a question on the wastewater fee. There have been some discussions in Vietnam. Is that an opportunity to attract more finance for the water sector and to do business in Vietnam?
I have to say, for industrial wastewater treatment, it's attractive enough now. For urban wastewater treatment, so far not yet. So we have the roadmap to increase the tariff, water tariff, and wastewater tariff. And if we don't have the cross subsidy and other supporting encouraging policy, the problem cannot be solved. So the plan is to provide full cost recovery for urban wastewater treatment. It takes some time.
Okay, thank you. Then I noted that the presentation of Jan Slange on the anaerobic water treatment options is very interesting. And my question would be that, is it correct that most of the water treatment at the moment is an aerobic water treatment process? And is that what Witteveen and Bos can add to the Asian market?
Yeah, thank you for Mr. Lauren. Yeah, most treatment plants are still aerobic. It's a long track record on aerobics. It's state of the art. More and more anaerobic treatment plants are installed, but it's typically for high concentrated wastewater. So it goes together with water saving in, first of all, in higher concentrations and make anaerobic treatment more feasible. There is also still some people are afraid to build anaerobic treatment because of the technology, but it has more and more advantages, and to save energy, and you should move to anaerobic treatment where possible.
Okay, thank you, Jan, for your explanation. We received another question from the announcement of this seminar that is related to the drought problems. At the beginning of the year, the Mekong Delta experienced a serious drought. My question is to Ivo, to which extent can this technology be used at household level, for instance, to store rainwater during the wet season and to make it available easily in the dry season?
Yes, thank you for the question. I've seen Mr. Niet Chan asked a similar type of question. Yeah, drain block can be applied for household levels as well, even though we normally only focus on the larger scale governmental projects. It is available for household levels. Here in the Netherlands, it's often applied by households. To store the water, yes, you can. As I've provided one example of a project where they put plastic liner around the reservoir. You have to bear in mind, though, that once the reservoir is full, it's full. So the volume you store is the only volume you can store, and that is freely available. So in generally, what we normally do in Asia is let the water infiltrate as much as possible. Very often there's a thick clay layer on the top, and then we go with pipes through the clay layer to enter into the sandy aquifer, so the water can freely enter into the aquifer. And that way you infiltrate as much water as possible, because otherwise the volume is limited while rainfall is really big in Asia. Does that answer the question?
Okay, yes, thank you, Ivo. That gives an idea of the scope, let's say, for the application of your technology. Furthermore, I would like to shortly give the word to Eric to see whether you have some questions that you would like to respond on live in our webinar. Your mic is on mute.
Yeah, thank you, Lauren. Now, there's a question on information. As I told you, I'm very happy to share all kind of information. And there's a question on the operational cost. I mentioned operational cost around 20 cents per cubic meter, which is compared to reverse osmosis, a relatively low number, which you have often much higher cost. But of course, yeah, that's also what Professor Viet Ang already mentioned. The water price in Vietnam is relatively low. That means there is also for me important to learn how that is to be seen in the context of Vietnam, this 20 cents per cubic meter. So that means if I'm able to make clean drinkable water for 20 euro cents from the Mekong or from wastewater, is that a solid business case in your part of the world, in Vietnam? Professor Viet, can you answer? Sorry.
Yes. Price of water is a very crucial issue, and the policy is to reach the full cost recovery. Not talking about the upgrading and improvement of the water quality, so that we don't have any micro elements in the water provided to the people. So we cannot satisfy with the existing water quality, even though it's very much has been improved over last 10 years. But I agree, we have to find the ways to have more efficient water production. So far from my studies, 0.35 kilowatt hour per cubic meter is the energy consumption, which is still needs to be more if we want to upgrade, if we want to add the treatment processes. So one way to do it is to use alternatives, which already today presented. We have some technologies like a low energy membrane, and instead of 5 steps, we need only one primary treatment and one membrane step. So we need alternatives. I think this is one of the solutions. This is one of the ways to go.
Thank you.
Yeah.
Thank you very much.
Okay.
I think also, sorry, Erik, I think that 20 cents comes down to 5 dong per liter. If you compare that with the bottled water that we buy, that's an attractive price. I think for many people in the Delta, they had to rely on bottled water. But if you compare it to the water tariffs of the households in the urban areas, for instance, it is much more costly. So it will depend also on your market niche that you are aiming at. But making the bridge between this Q&A session to the next session on the business to business interaction. I think, Erik, you already explained that you are looking for a partner who can then use the membranes that you are producing in order to manufacture the end products, if I understand correctly. And you also look for a business partner who can help you with the proper marketing of the membranes. So that is exactly the purpose of this session, which we call the B2B moment. I would like to invite all people that represent businesses to raise their hand if they have any question or any request. I only want to invite business representatives in this session, but both from Vietnam as well as from the Netherlands. If you have a product that you are interested in, or if you have a service that you want to buy or to sell, please, this is the moment to raise your hand and express your interest to find a business partner who can match with you and who can meet your needs or who can buy your products. So please raise your hands by pressing the icon at the bottom of the screen of you, and the Informa people will allow you to open your microphone. Is there anyone from the business community who is looking for a business partner in this webinar? Okay, we are. Okay, I see Mr. Huy Tuan Bui is raising the hand. Can you talk? Can you and Mr. Yen Chan? Can the platform manager enable your microphone? I see also that Mr. Ivo Bastings is sending a message in the chat that they are looking for a Vietnamese distributor.
Yes, correct, Laurent. I'll take the floor,
yes.
if that's okay with you.
No,
Yes,
no, I
indeed.
would like to give the floor to Hien Chan or
Okay.
Paul van Grift, who is raising their hand.
Okay.
Or Mr. Huy Tuan Bui.
Hello.
Yes. Yes, please, Paul.
Hello, good morning, good afternoon. This is Paul speaking from Lucon International in the Netherlands, calling from home in Amsterdam. We are also looking for distributors in Vietnam, and we are offering non-biological wastewater treatment units, containerized. So looking potentially for production locally, but definitely sales distribution network. So I just wanted to put that out there.
Okay, thank you, Paul. Looking for distributor and sales. Then Mr. Huy Tuan Bui, can you unmute your microphone and tell us what you are looking for? Or Mr. Hien Chang, can you unmute and raise your interest?
Yeah. Hello. Hello, everyone.
Yes.
Did you hear me?
Yes, yes. Please raise your question or tell us what product you are looking for or what product you have on offer.
Yeah, we really want to ask about that. Do you have any project for a cement plant to treat the water used in a cement plant in Vietnam or any countries in the world? Because the customer in Vietnam, we really want to develop the water treatment for cement plant, and our customer also almost a cement plant in Vietnam.
Thank you very much, Ms. Jan. Then I see Mr. Bui Tuan raising the hand. Can you unmute your microphone and express your interest in a business partner? Okay, you can always later connect us because the time is running and I would like to close this webinar with some summary remarks. The Vietnam's water resources are increasingly under pressure and water users are putting multiple and competing claims on those resources. Vietnam is not only vulnerable to climate change, which changes the water conditions, but it is also increasingly facing the negative impacts of its past developments, the Industry 2.0 and 3.0, which have resulted in the overexploitation and pollution of its water resources. So substantial political, financial, and technological investments are needed to maintain adequate quantities and qualities of water. It is now more than ever that we need smart technologies, nature-based solutions, and innovative partnerships. We have seen in this webinar that Dutch water technology providers can play a role in addressing the challenges in Vietnam, and I hope that they can find the right business partners. If you want to receive presentations, please mail us at the address which is given on the screen. And also please fill in the survey that you can find in the chat box so that we have an appreciation, that we have your appreciation for these webinars. All in all, I would like to thank everybody, the presenters, the viewers, and the participants for this webinar. And I wish you a lot of success in doing business in Vietnam and with the Dutch companies. Thank you very much, and hope to see you again.
you.